Hello. The following video will present a unique solution to a common problem. A problem that deals with base stabilization of roadways over poor subgrades. The solution to this problem? The Geoweb cellular confinement system. The Geoweb, a unique construction product, is manufactured by the Presto Products Company. Now, before we get into the portion of the video showing two successful applications of the Geoweb, let's review the theoretical aspects of the Geoweb cellular confinement system.
The Geoweb system is an assembly of high-density polyethylene panels that form a durable three-dimensional cellular confinement structure when expanded. The high-strength bonds which integrate the system are the result of Presto Products' unique welding technique. The Geoweb system's advantage results from the hoop strength of the cell walls and the passive resistance developed in adjacent cells. This unique concept of lateral confinement increases shear strength of structural fills. Under load, high lateral confining stresses and structural fill Geoweb cell wall frictional forces are generated. These combined effects prevent penetration of the infill materials into soft subgrades and establish a beam effect which adds stiffness to the system.
The remainder of the video discusses two specific jobs. The first demonstrates the Geoweb cellular confinement system being installed to solve a stabilization problem. This problem was a stormwater stream crossing on a road being built to construct and service a Florida power and light transmission line. Also, it should be noted that both of these projects were reviewed and approved by the Environmental Protection Agency. It was determined that the Geoweb was the only method of road building they would permit in an environmentally sensitive area. The EPA was impressed that the Geoweb road construction would produce the very least disturbance to each local environment. First, the ground had to be cleared of vegetation and approximately 18 inches of topsoil removed. This was necessary to provide a ground-level finished road surface through the stream crossing. When the topsoil was removed, it revealed an almost liquid muck subgrade. A geotextile was laid over this surface. Rock was dumped on the geotextile to be leveled to a 6-inch subbase for the 8-inch deep Geoweb road surface. The bulldozer had tremendous difficulty spreading the stone because of the poor subbase conditions. Because of weight and lack of support from the geotextile, severe rutting occurred. Additional stone is placed over the geotextile. Note how the truck sinks into the stone geotextile layer because of the lack of support. Again, additional stone is brought in and the system is unable to support the weight of the truck. As the bulldozer attempts to spread the additional stone, more severe rutting occurs. As additional stone is brought in to spread over the initial geotextile layer, the weight of the truck causes a blowout of the geotextile, which then must be repaired. To avoid the rutting that was caused by the bulldozer, a lighter weight tractor with a spreader box is used to spread the stone. A roller compactor is brought in to attempt compaction of the stone and to create a more uniform surface for the installation of the Geoweb. An additional layer of geotextile is placed over the prepared stone base. Geoweb sections are then stretched over the geotextile. Additional sections of the Geoweb are placed over the geotextile and are fastened together using hog rings. Stone infill is then dumped into the Geoweb cellular confinement system and spread, in this case, by hand into cells that were not filled during the dumping process. A log ramp or corduroy road system was built to bring the front end loader, filled with stone, onto the Geoweb. Notice the movement that occurs in the corduroy road system and the stability of the infilled Geoweb over the poor subgrade conditions. As the front end loader dumps additional stone onto the Geoweb, the big end loader, with its heavy axle weight, moves right on top of the Geoweb with no visible rutting, even though the infill material has not yet been compacted. This is an excellent example of how the Geoweb cellular confinement system changes granular fill into a soil slab system. After the first section of this road was completed, the same process is repeated on the second section, starting with the spreading of the geotextile over the poor subgrade conditions. The Geoweb is again placed over the geotextile 6-inch stone geotextile sandwich layer. As the newly laid sections of Geoweb are being infilled, we can easily see the support that this plastic soil interaction system adds to the poor subgrade conditions. Clearly, the Geoweb is a unique solution to this problem. As the heavy front-end loader passes over the filled Geoweb sections, loaded with a bucket of additional fill material, we can see why the Geoweb cellular confinement system provides a cost-effective and unique solution for stabilization over soft subgrades. Tampa Electric Company has also used the Geoweb cellular confinement system solution for its road building problems over soft subgrades. Here, the soft sub-base material is being prepared to receive the geotextile. The geotextile is then stretched out and laid over the soft subbase. In this solution, Geoweb is laid directly on the first and only layer of the geotextile. The Geoweb is held in place on the geotextile by filling the edge cells with sand infill. A front-end loader brings the sand, which is then used to infill the remaining Geoweb cells. One of the workers steps off the Geoweb area, sinks into the mud, and has a very difficult time getting out. The Geoweb is filled. The completed Geoweb installation provides a very stable road for the Tampa Electric Company. Thank you for taking the time to watch this video. I believe after viewing this informative video, you will agree that the Geoweb cellular confinement system is the solution to your difficult stabilization problems. Thank you.